Hello learner, welcome to the learning of computer networks and security. Let's continue with the module 3 concepts. Let's discuss now the protocol, that is routing protocol, and one such routing protocol here is RIP. We'll be discussing that here. We call this routing protocol as intra-AS routing. So here we have two types. One is intra-AS routing and one more is inter-AS routing. So here RIP is the protocol which we are going to discuss now. That is intra-AS routing protocol. So what is intra-AS? It is inside the autonomous system. Within the autonomous system, this routing protocol is implemented. So we have three such intra-AS routing protocols. One is RIP, next is OSPF, and the last one is IGRP. So here we'll be discussing the first two protocols, RIP and OSPF. So out of that, now we will discuss what is routing information protocol or RIP. We have this RIP, which is implemented, as I said, inside the autonomous system, within the autonomous system. So let's consider one such autonomous system. So let's call this as an autonomous system which has a group of routers. The routers are A, B, C and D. And you can just see here many subnets are connected to these routers. So those subnets are X, Y, two subnets connected to router D. Then we have Z, which is the subnet connected to C, and then you have VW, two subnets connected to router B, and finally the subnet U connected to router A. So this is a autonomous system, and you can just have a look at the routing table, or you can also call it as the forwarding table. So who is maintaining this routing table or forwarding table? It is all these routers should maintain. So one such sample is shown here of router A. This is actually the routing table or the forwarding table we have of router A. So what is the forwarding table contains? It contains two columns or the two information. So first column is subnet. First column is subnet. The second column here is hops. Okay. So what is that subnet and hop? You can just see here. The first subnet reachable from router A is U. So what is the cost to reach from router A to subnet U? It is just 1. So here the hops cost, or you can also call it as hops, number of hop to reach the subnet U from the router A is equal to 1. Next, subnet V, the from the router A, you can just see here, from router A to the subnet V, you can reach a number of hops. How many hops? A to B 1 hop and B to V it is 1 more hop. So 1 plus 1 is equal to 2. So total 2 hops to reach the subnet V. Similarly, the subnet W is reachable from A via B through 2 hops. 2 hops again, right? So next we have the subnet X. So here subnet X is reachable from A via B and D. So the number of hops is 1 plus 1 plus 1, total 3. So total 3 hops. Similarly, the subnet Y also is reachable from A through 3 hops. Finally, our subnet Z is reachable from A in 2 hops, total 2 hops. So this information is actually maintained in the forwarding table of router A. So same such a forwarding table is also calculated at router B, router D and finally router C also. Okay. We'll just see an example here. So what is an example we have here? You can see one particular network, and that network here contains routers A, router D, router B, router C, and there is one more router which is actually connected through this dashed line. What is the meaning of that? The meaning is there might be some intermediate routers in between. So here this is a router which is far from all these routers. Okay, so you can see here there is also a dashed line which says that there can be a connectivity from this router C to this router or any other routers. Okay, dashed line is there might be some intermediate routers in between which connects to other router, right? So or assume that all these routers are part of same autonomous system, and you can see this subnets here again. W, X, Y and Z are nothing but our subnets here, and you can just see here this is an interface which is connecting the multiple routers. So this is an interface which connects router D and B. Again, you can see all these are the interfaces which are connecting. Okay, so you can see in this example routing table also is shown, but that is shown for only one router, and that is router D. So we'll see how router D calculates its forwarding table. So here remember one point in RIP, this protocol actually makes use of distant vector algorithm to calculate the shortest path. So distant vector or Bellman-Ford algorithm is used to calculate the shortest path. And as per our distant vector algorithm, we know that the distant vector is calculated by every node, and that information is shared among its neighbors. Similarly, B, A are the neighboring nodes of this router D, and here D is getting the information or the shortest path or the distant vector what router A has calculated and also what router B has calculated, and we call this sharing of distant vector as sharing of RIP add. So instead of calling it as distant vector, we are calling it as advertisement or RIP advertisement what the neighboring nodes are sharing with the router D. So we'll just see here just initially the routing table what D has calculated, and you can see the routing table for D where information is about destination subnet W, X, Y, Z. So the cost to reach these subnets, or you can say the hops to reach these subnets, are also included in this table, and the next hop router via which router you reach these subnets, that information is also maintained in the routing table. You can see the first subnet is W. So from the router D, you can reach W in how many hops? So one hop to A, and then via A to W next hop. So total 2 hops you can see, and you can see the next router is from router D. It is the subnet W is reachable via the router A. So next router is A. Similarly, you can fill the other entries also for subnet Y from router D. You can reach through 2 hops. So again 2 hops, and via which router? It is via the router B. You reach the subnet Y in 2 hops. So that is shown here, and now you can see here there is a subnet Z. So what is that subnet Z here? It is attached to this last router, and you know that D can reach this last router via B. Through many intermediate nodes, it can reach finally the subnet Z. Right? So here we can assume that this information, the cost to reach from D to this final router or to this final destination Z, that assumption we are making it as 7. So what is the meaning? There might be some other intermediate nodes here in between. So the cost is 7, and via which router we have reached there? Z, it is via router B. And finally, I have X also, which is directly reachable from router D at the cost 1, and next hop router, there is no next hop router for that, right? So this is actually the forwarding table that is calculated for router D. Now we'll just see what happens in the same example, what happens when our router D gets the RIP add from the neighboring nodes, that is A and B. So how the routing table changes, we'll see after it obtains the RIP adds from its neighbors. See here, this is again the routing table, what we can see in this example. Yes, so it is W, Y, and Z and X. All these are reachable. So here in this instant of time, first instant of time, you can see the routing table of D has not changed. We'll see the next instant of time. Next instant of time, that is when the add reaches from router A to router D. So what is that add containing for router A? It contains its forwarding table. So here you can see just W, X, Z are the reachable subnets from router A. And what is the cost? For X it is 1, again W it is also 1 again, and but Z you can see A is saying that it can reach Z via the router C. So where is our router C? You can just see here, router C is here. Via router C, you can reach this subnet Z. So what is the cost there? The cost is 4, it is saying. So 1 is to reach C, and from C to finally Z it can reach through 3. 3 cost is 3, total how much it is? 4. So 3 plus 1 is 4. So you cannot see this intermediate routers, but still A is saying that via C it can reach this destination Z. So that is the add what A is providing to our router D. Now with the help of this add, our router D has to update its forwarding table in next instant of time. We'll just see that how our routing table will update that. So after it obtains the information from A, it just checks its subnet, its forwarding table. Okay, so whether it has to change this first W subnet. So it knows that D can reach A in one hop. Again, A can reach this W in one more hop, right? So here this cost it cannot change. It is same too. Again, our D also knows that Y is reachable through 2 hops. So here also, here it doesn't have, but again that is the same information. But what about this Z? D says that D can reach Z via B at the cost of 7. But A has told D that it can reach the subnet Z, same subnet Z, at the cost of how much? 4. At the cost of 4, D A can reach Z at the cost of 4, but D knows that it can reach A at the cost of 1. So total cost or total hops to reach from D to the destination Z is how much? 4 plus 1, that is how much? 5. So A says that at the hops through 4 hops it can reach the destination Z, but D knows that it can reach A in 1 hop. So total hops to reach the destination Z is how much? 4 plus 1, that is 5. So this is actually how the router D updates itself after obtaining the RIP add. Suppose here if the link fails, suppose here if any link fails in between in RIP, such a failure of link can also be sorted out through our Poisson reverse problem, Poisson reverse solution. So we have Poisson reverse solution explained. I had explained this already. So this Poisson reverse can be used if any in between link fails. Okay. So finally we have our table processing. RIP table is actually processed at the application layer level. So this table processing this is managed actually at the application level process called daemon process. And this advertisements, whatever RIP advertisements are there, that is sent through UDP protocol, that is a transport layer protocol UDP. Through this protocol the RIP advertisements are getting exchanged. But finally remember, this forwarding table is maintained or calculated at the network layer only. At the network layer only this forwarding table is calculated.